Hello, everyone. Welcome back.
Hello.
If you've been on the other sessions, so this is the third Ask IX presentation on the new ProAnalyst 2023 by Excitex. I'm Shane. I'm an application engineer at Excitex, and today I'd like to do a brief recap of what we talked about in the last two sessions, and then talk about 3D, which we haven't gotten to yet, and give a couple more in-depth examples of some of the specialty analysis toolkits. So to start the recap, so in the first session, Peter talked about ProAnalyst 2023 in general and how there have been a lot of changes made to the underlying structure of ProAnalyst, the licensing paradigm, and how that affects the selling strategies, how the toolkits in ProAnalyst can now be licensed a la carte, so people aren't locked into these big packages that they may not end up purchasing because they're too daunting. They can get just what they want, which is really helpful. And he talked about the new ProAnalyst Essentials. I then followed that up by talking about just going through an example workflow, an analysis workflow in ProAnalyst. I talked about calibration, image correction. I did some basic tracking and then some graphing. That was just to give you a sense of what ProAnalyst can be used for, how quick a process could be. The next week, last week, I went through all the 21 toolkits. I'm going to pull up the website here while I'm doing this. So I went to the Excitex website, and I just went through all of the analysis toolkits that are available, the 21 analysis toolkits. So here's the website, here's the ProAnalyst page, and then toolkit section. Went through and talked about each of these tiles here. Each of these represent a different analysis toolkit, and there are some comparison charts for the different sections, specialty analysis, calibration, etc. And all of these can be licensed individually. I did not get to 3D last time, and 3D is a very important part of ProAnalyst. It's one of the things that ProAnalyst does very, very well. And that's what I'd like to demonstrate today. So first, I'd like to just talk about 3D in general. So 3D is, it requires two cameras. One camera by itself has a hard time understanding depth in an image. And with two cameras, ideally spaced apart, maybe 90 degrees that they're pointing perpendicular to each other, then you can get a setup where you're getting a lot of depth information about the scene, which allows you to do cool things like 3D reconstruction, a very powerful tool for any motion in 3D that's happening in a relatively constrained area, but you can have rotations, you can have motions back and forth, and that can be captured with two cameras and then analyzed in ProAnalyst. The reason why two of the three 3D toolkits are here in the feature tracking section is because 3D in ProAnalyst is set up to work seamlessly with feature tracking. And I'll demonstrate that in a few minutes. These feature tracking toolkits allow you to track things in 2D, and then this one, 3D stereoscopy, allows you to take multiple, specifically two 2D data sets and then combine them with a 3D calibration and get 3D data. So there are ways to get data from some of the other toolkits into 3D, namely through virtual points, which I believe I demonstrated last time, where you can import data from particle tracking or contour tracking into feature tracking. You can then take that data and make it 3D, again, assuming that you have two cameras and a 3D calibration. So that's 3D stereoscopy. You are using a stereo configuration of cameras, and you're getting information, 3D information about the scene. 3D multi-camera arena is the next step up. With this one, you combine multiple pairs of 2D data. So I have cameras 1 and 2, cameras 2 and 3, let's say I have 6 cameras. I take all of these different pairs of cameras and I get 3D information from those, and then I can merge all of those with weights that I can set, and I can get a more comprehensive understanding of a 3D scene that maybe has some more complicated motion. That configuration of cameras, having a large number of them around a subject, is what we call arena. So the third analysis toolkit is the third 3D analysis toolkit is down here. This is 3D stereo calibration. This is one of the pieces required to produce 3D data along with the 2 cameras. This one is separated because it's possible that in the future there might be other ways to do 3D calibration beyond what I'll show in a few minutes. But at the moment, 3D stereo calibration combined with 3D stereoscopy is how you take 2D data sets and combine them to make 3D. So I'm now going to jump into ProAnalyst to demonstrate that. So I'm opening ProAnalyst 2023, and I'm going to grab here an example video. It's a simple example, but it will demonstrate the power of 3D. All right, so I'm going to drag in a project like I've done before. We recommend that all users start with a project. And you'll see that previously, when I was doing 2D, I might have 1 or 2 videos, but they're sort of either multiple steps in the process. Like I have one that's stabilized, one that's processed, that's gone through image processing. Here, these are videos from 2 completely different cameras that were recording a subject at the same time. And then these images here are images of a calibration fixture. And a calibration fixture is used in 3D calibration to give ProAnalyst information about the measurement volume. That's the volume where the measurement, where the experiment takes place. And all that's required for that is a known object, an object with known size. If you can see my camera here, I have one on my desk. This is an Excitex made 3D calibration fixture. These are great. They're designed to work with ProAnalyst, but you can use any calibration fixture if you have information about its size. So here, all these black dots on the calibration fixture and all the dots in these ones here. Let me open this up so it's a bit larger. All of these dots have positions in 3D space. I believe that the origin, the 0, 0, 0 point of the 3D coordinate system is usually set right here at the bottom of the fixture. And all of these dots here have 3D positions that are listed in what we call a fixture file, which is just a text file in a specific format that gives ProAnalyst information about where these dots are. And if ProAnalyst knows where these dots are and it can find them in the image, it can do what we call 3D stereo calibration and get information like where the cameras are in 3D with respect to this calibration fixture. And if you know where the cameras are and you have videos like these of some test from 2 different angles, then you can get 3D data. So this here is just a video of a toy robot doing a dance. I have the toy robot behind me there on my desk, and this toy robot is going through its dance, and it has some features that can be tracked, like this here. This maybe you'd call it the navel, the belly button. So I can go in and do all of my tracking in 2D. The process is exactly the same. To start, you're doing some simple 2D tracking. Make sure I'm only showing the current points. I can set the template, and then I can track forward in time, right? So it'll go through the video, and it'll look for that feature, and I can do that with a bunch of different features, anything that I'm interested in. So to save time, I'm going to click this button here in the project, and I'm going to load up the full completed feature tracking here. So you can see you have all of these points, features that have been tracked. I can hide the lines there. And as I scrub through, you can see that they follow the motion of the toy robot. So now I'll bring those lines back. So I go through that 2D feature tracking process for both of the videos. So I also have this one tracked all the way through, as you can see. and I have my list of features, and then I want to make sure that in my calibration images here, they just need to be images, they don't need to be videos, and they can be taken before or after, just like a 2D calibration, as long as you know its size. I can do some simple LUT adjustments to try to get those black dots as stark as possible on their white background. I'll do the same with the other one here. Okay. And now that I have that, I'm ready to go into 3D. So to do so, I'm going to go up under Tools, and I'm going to open a 3D Manager window. Here you can immediately see that there are 4 empty boxes, and these are for my 2 calibrations and my 2 measurements. So here I have a file called cal1 _0.jpg. I'm going to put that in the calibration 1 box here. And I have my second calibration. I'll put that in the other calibration box. And then I can do the same with my videos of the test, my measurements. So now all of these are loaded in, and then I can go to calibration. So calibration, I just need to tell ProAnalyst where these dots are, and it will find them. It will mark their locations, and then I give it information about where they're located in 3D. So let me get the fixture file here. Go out to, let's see, I'll just grab the file path here. Fixture, so I'm just going to grab this fixture file. It just looks like this. You have, for every dot on the calibration fixture, you have a 3D position, and image XY, these are -1. That means there's no data yet because ProAnalyst hasn't found the dots. We need to give it a little bit more information. So the process is very simple. I'm going to make this full screen so it's easier to see. The process is very simple. I make sure that I'm looking for black dots on a white background. I click Define First Region, and I draw a shape around these black dots here. There are these faint markings in the corners of this fixture, and that indicates to me the edges of the region, so I don't want to go outside of those. But now I have these 6 points in, and it will look for the dots in that region. So now I can do the same on the bottom here. Click my 6 points. It's very important that they are clicked in the same order. They don't need to be placed in the exact same position, but the order that they're in will help determine the coordinate system. And so now I can say locate both top and bottom. ProAnalyst will go through and it will look for all of the dots, see if it can find them. And when it finds them, it will place these green crosses at the center of each of the dots. So it's found all of them. I can open up Display and Edit Points, and you can now see that for every dot on the calibration fixture, I have a 3D position and a 2D position. And that's all that's required for 3D calibration. So now I have done this pretty quickly. Let's see if I can actually get it to calibrate with what I've done. Oh, I can. Okay, so this is the calibration. I just click Calibrate. It goes through, it runs its calibration algorithm, and then it reports the error in whatever units I want. I have it set to inches right now. Let me open up this this finished calibration here, so you can see I have all of the points in here. It's calibrated. You have the coordinate axes there on both images, so it knows where everything's supposed to be. And now I can click Graph Points, and what it will show me is a graph in 3D of where the cameras are with respect to the fixture. Let me make these cameras different colors so they're easier to see. So these yellow dots here represent the cameras, specifically, I believe, the centers of projection of the cameras. And those dots over there represent the calibration fixture. You can see it has that same shape there. And I can align the yellow dot roughly in the center there, and I get an image that looks very similar to that. You can see it's in the same sort of orientation, and I can do the same with my other camera, and I get a very similar orientation to that image. So that is the calibration done. ProAnalyst now knows everything about the 3D scene all that remains is to give it information about our measurement, and then it can return 3D data by combining the 2D data sets. So the way that it's done is you go in and you just choose a feature from each video and you correspond them. That's what we call this step. You're doing correspondence. You're saying feature one, let's say the elbow of the robot in this image is going to be the same elbow in this image. And as soon as ProAnalyst knows where that feature is in both images, it can say, all right, now I have these two 2D data sets, I can combine them and make 3D data. So that's already been done. In this list here, you can see it says 2D feature 2, 2D feature 2. So it's already connected all of these. And so I can simply go to graph points. And when I click graph points, it takes those 2D data sets, it combines them, and it gives me data in 3D. As I move the graph around here, you can see that data exists in 3D. I'm going to make sure that I have fixed coordinate axes here just so that it doesn't wiggle around while I'm trying to demonstrate this. And when I scrub through the video, you can see the arms of the robot going out, and then they come down, and then it shakes side to side just like it does in the videos. But this is not a great visual. You can see the joints, but you can't see any of the lines connecting them. So I'll just do this one because it'll be quicker. You can go in and connect all of them with lines, and then you get a graph like this. So make sure these are fixed. Yep. As I scrub through, there's the robot. So just from 2 cameras, 2 measurement videos, and 2 images of calibration fixtures, I can create very simply this 3D reconstruction of the scene. This works for drop tests when things are falling and maybe rotating at the same time. If you have multiple cameras, you can see how fast it's rotating. This works for some explosions. If you have large pieces that are going off in different directions, you can feature track those, and then you can combine your information from multiple cameras to get its 3D trajectory. So it's a very powerful tool. And again, in order to have access to this tool previously, and to all of the tools in this 3D stereoscopy toolkit, users would have needed to purchase the 3D Professional edition of ProAnalyst, of Legacy ProAnalyst, which comes with a lot of other very useful tools, but maybe tools that they don't need, and that might scare them away from purchasing. But now, if someone wants to get the levels of feature tracking and then just 3D, they can. And so this is a quick way to bypass that barrier to entry for doing 3D analysis. And it's very powerful. It's very easy to do as long as you have 2 cameras and a calibration fixture. So that is 3D calibration and 3D stereoscopy. This 3D, let me close this here. This 3D manager window that I had open here, it's like the 2D measurement window in that it has these control panels that you can access from the tabs on this side. The 3D stereoscopy and 3D calibration toolkits are sort of dispersed among these control panels. So all of the functionality that those 2 toolkits give you, you can access from this window. So that is 3D analysis with 2 cameras. It gets more complicated with more than 2 cameras, and that is what I will talk about next. That is 3D multi-camera arena. Before I jump into that, I just want to jump back to the website, make sure everything is clear. 3D stereoscopy, you go from feature tracking, from 2D feature tracking data sets to 3D stereoscopy, and that requires calibrating. And so if someone wants to get the 3D stereoscopy toolkit, they must also get the 3D stereo calibration toolkit for now. There may be new ways of calibrating in 3D in the future, but that is the setup at the moment using a static image of a 3D calibration fixture, which is, again, just a shape with known dimensions. So 3D multi-camera arena is the next one, and I really have only one good example of this. We do have access to this one, so I'm going to use that one to demonstrate. Let's see here. I'll jump back to ProAnalyst 2023. I'm going to grab a project again, because we always recommend that the users start with their project window. And here you can see there's a lot more in this project. Namely, we have 4 different videos from 4 different cameras. There's also, this project has been moved around a bit, so there were some references to the calibration fixtures. They aren't here at the moment, but once again, some sort of calibration fixture is required to give ProAnalyst an understanding of space and an idea of where the coordinate system is centered in 3D. But I'm just going to do a simple walkthrough of this. This can be a bit more complicated of a process, but it's very useful for when you have complicated motion and you need to get more than just views that are perpendicular to each other. You need a camera behind your subject. You need cameras everywhere. Then you want to go for 3D multi-camera arena. And again, this is great for drop tests, for explosions, anything with complicated 3D motion. So here I'm going to just open up one of these videos to demonstrate what is going on here. These are videos from SUNY Stony Brook in New York. These are videos of a chimpanzee named Hercules walking across some force plates. So these plates here are recording force data, and that's what these graphs are. That's available in the advanced data graphing toolkit. So they're getting that information, and they're also getting information about the motion of Hercules' leg and arm, because they have they put these dots on. These are just white paint. And they wanted to get a really comprehensive idea of how his leg is moving in 3D for this particular project. So they went through and they just did some simple tracking. Let's see if these have their tracking files. Okay, so you can see there's some tracking done here. I can hide the labels, hide the search areas, hide the templates. These little symbols here represent all the features that have been tracked, and so they just went through and tracked all these different dots. As I scrub through, you can see those moving. So they can get that from this angle, and they can do that for all of the different angles that they have. They have 4 different cameras set up in this custom motion lab that Excitex worked on. So here again, you have these. This is displaying all of them through time, not just for the current frame. So you can see how many points have been tracked here. And once again, they go through and they open up the 3D Manager window. So here I've opened up something in the project that was called 3D Manager. It's titled Cameras 1 and 2. So this is combining the data from the camera 1 video and from the camera 2 video, just like before, just like with the toy robot. 2 2D data sets, combine them with a 3D calibration to get 3D data. Great. The problem is that there are some dots on the chimpanzee's leg that aren't visible from those 2 camera views. Some of the dots were on the other side, or they were on the top of the foot, and so they needed additional cameras in order to see those. So this is a great start. This will give them some 3D information, but they also needed some information from cameras 1 and 3, and maybe some more information from cameras 2 and 4, and 2 and 3. So every pair of cameras, they have a different 3D manager, which is combining those data sets into 3D. And now they have 1, 2, it looks like 6 different 3D managers, each handling a different pair of cameras. So that's a lot of different 3D data sets, and some of them have information that others don't. So to combine all of these into a single comprehensive 3D data set, they use what's called the 3D Merge window. And that is, once again, up under Tools, new 3D Merge window. And this one, you go in and you add 3D Manager windows. And then you can specify a weight. So you can say, well, this data set came out really clean. the calibration had a very low error, and so I want to use this one with the highest weight. And you can also do unweighted. Yeah, here we have weighted average using uncertainties, weighted average using fixed weights. Those are user determined. And so you can load in all of your 3D managers and then merge them with weights. I'm going to open the one that's here already. This is called just 3D merge. That's the title of the of this file. So you can see one by one, it's going to load every single 3D manager window and all of the data therein. And then lastly, it'll load the 3D merge window, and I can go in here and I can see here all of my different 3D manager windows loaded in. Now, there weren't any weights specified for this particular project, so I'm going to change this to just an unweighted average. And then I can click the merge data, but I think that's already been done. So I'm just going to click graph points here, see what we get. So it's going through, it's merging all of the data, and it produces this graph. Now I'm going to hide some of these other things just so the screen isn't as cluttered. So here I have a 3D graph, once again, just like with the toy robot. Because of how the calibration was done, I do want to warn you, what you're seeing is the foot, but it's sideways. So the ground is actually this plane here. This is the, let's see, this is the XZ plane. So this plane here is the ground. In fact, I'm going to hide everything except the XZ plane. So that's that's parallel to the ground there, and here is the monkey's foot, the chimpanzee's foot. Excuse me, they're apes, not monkeys. I'm going to show only the current frame. You can see the chimpanzee stepping, and then stepping away. I'll show that from the side just so it's clearer. So there's the leg right there. The leg comes in. There's the foot. It steps, and then the foot leaves the ground. And it would be a lot clearer if I were to connect all of these with lines. I can do that very easily just by going into stick models and saying, yeah, I want items 1, 2, and 3 to have some line between them. I can go through and do that, but you can see that these dots represent the different dots that were on the chimpanzee's foot, and here you get this data. I mean, the data for the I don't know what you'd call it, the equivalent of the thumb on the chimpanzee's foot. This is data that you can't see from cameras 1 and 2, for example, because it was on the other side. Just to remind you, the leg that was being tracked here was the outside leg. Let me hide these here, and then show only the current. The leg that's being tracked is the one on the outside, which means that thumb, if you'll call it that, is on the inside. So some of the cameras can't see that when the chimpanzee actually makes contact with the ground. But with 4 different cameras, that's information that you can get, and then you can add into your comprehensive 3D data set. So whenever you have really, really complicated motion and there's some features that you want to track, but you can't see from only 2 cameras, 3D Merge is a great tool. And once again, this is a tool that most users will not have ever interacted with. A lot of them probably don't know it exists because there was such a high barrier to entry. You needed to get the full Extreme Legacy ProAnalyst edition in order to ever even see this. And now if someone wants this, they can buy they can license as few as 5 toolkits in addition to whatever they have in their toolbox. And with the IX toolboxes, some of those will already be included, so they may only need to license 2 or 3 in order to get access to this. So these toolkits are very powerful for 3D analysis, and as long as the user has multiple cameras, then they can do any of this, and they can get really interesting depth information that they can't with just a single camera and the 2D tools in ProAnalyst 2023. Okay, the next thing I'm going to go into is I'm going to talk about a couple of the specialty analysis tools that are available in ProAnalyst 2023. I talked about a couple toolkits last time, very briefly. I wanted to do a bit of a deeper dive into them, show a little bit of how they work, and what sorts of videos what applications would be best served by using these particular toolkits. So the ones I'm going to talk about specifically are particle tracking and contour tracking. So I'm going to start with contour tracking. I'm going to pull up, in fact, I'm going to pull up that video that was in that image. Let's see. Okay, so here's my video. This is actually an image sequence. And this is a video of an airbag deploying. I should pause here and say, even if the customers that you're talking to are not working in the automotive industry, you can think about this as great for analyzing any evolving surface. For example, if there's any sort of explosion and there's a fireball produced, that will end up being a really bright light, a bright hotspot on a relatively dark background. And that is equivalent to this case where you have this bright airbag on a dark background. And so if you want to get information about how rapidly it's expanding, the area of that shape or the perimeter, anything like that, contour is a fantastic tool, and I'll demonstrate that right now. So I have this video here, and I know that it's changing shape as it's expanding, and I want to get its shape at every frame. So I'm going to enable contour tracking, and a contour loads up automatically. You can have multiple, but when I click on the settings here, the settings dialog will appear, and I can say, what do I want it to look for? I can either look for the largest shape in the image. I believe that by default it's looking for a white shape on a dark background. I can look for the largest shape. I can look for a shape that includes the initial point, which right now is set to nothing. -1 in ProAnalyst means no data. But I can put my reticle here, and I can say, oh, I want it to include my reticle point, which is at 350 pixels by 346 pixels. So that's the X and the Y values. And then I can click apply and then close, and then I can click the button here, which is track this frame. And when I do, you'll see some data appears. When I zoom in here, there's this green outline all along the edge of the shape, everywhere where ProAnalyst found a boundary between light and dark. If there are gaps like this, then it'll exclude those. It's looking for a closed shape. And this will be a little bit harder to see, but there are these squares in there. In fact, let me change the color here. There we go. So there are these cyan squares, these little points, and you can set how many points you want in the settings. I believe you can set your point spacing and your line thickness, and it will find the contour. And then if I click track backward, every frame you can see it's outlining it in red until it's gone. And as I scrub through, I can go back to the last frame where I had data, and then I can scrub forward instead, or I can track forward instead. Once again, for every frame, it will find this shape and it will outline it. So this is incredibly powerful. It goes very fast, and it does a great job at characterizing this shape at every frame. Again, if you want to get a better characterization of the surface, like you want to include some of these things on the outside, I mean, it is doing a really good job, but occasionally there will be something that's a little bit darker, and so it doesn't get caught, and you can adjust your image processing settings at any time, retrack, and it will update automatically. So let me switch back to the processed view here, talk a little bit about the information that's displayed. So here's the contour. It's contour 1, as you can see in this list over here. CG, the center of gravity. It's just effectively the geometric center of this shape. And this says that it's at these coordinates here. It looks like it's in inches, so I must have some calibration set here, and some origin as well in my coordinate system. Yeah, so here's my origin, and so the center right here is 0.18 by 0.41 inches away from that origin. So I get that information. I get the perimeter. Again, that's going to be in whatever calibrated unit I have. In this case, it's in inches. And then I have the area, and that's going to be in the squared unit of whatever you set. So if you have your calibration in meters, then your area will be in square meters. And so this is a very powerful tool, and it runs fast, as you saw. And I can get a lot of this information into my graph and then out of ProAnalyst. So here already you can see I have an export just like in feature tracking. And I can export in whatever units I want. I can export to a text file or to an Excel file. And then I can also go down to my graph configuration control panel. This is where I have access to my standard data graphing and advanced data graphing toolkits. And I can add a new graph line. It automatically detects that I've done some work in the contour tracking toolkit. So I can click this, this list to expand it. And then I have all of these quantities to choose from that I can graph. So let's say that I want the distance of the center from the origin of my coordinate system. I just select that, I click OK, and then there's the distance. So here's my profile. I can scrub through that, and I can see at any point where that data is. So that's one piece of data that I might be interested in, but I might also be interested in something like the area. So I'll go to Contour 1 area, and this is my area profile. So you can see that right at the beginning, when the airbag goes through its, I opened something here. When the airbag goes through its most rapid expansion, you can see that you have the steepest slope in the area. So this is where it's changing most rapidly. So a lot of useful information you can get out of Contour, and once again, airbags, but also fluids. If you have a pipe with fluid flowing through it, and let's say that the pipe is semi-transparent and you can see through it, so the pipe is maybe translucent, and the fluid is something dark on a light background, or maybe it's something light on a dark background. You can get information about how that area of fluid is changing. Or if you have an explosion and you have a fireball that's changing shape, you can get information about that with Contour as well. So overall, very powerful tool for characterizing evolving surfaces. That's sort of how I describe it. So and this one, once again, doesn't require any other toolkits to be licensed. You can just add this on to any toolkit, any toolbox, any set of toolkits that a customer has. You can license this, and then they'll be able to use it immediately. So it requires no extra technology. And I'll talk a bit more on that at the end. So that's Contour. I'm going to close that example here and pull up one for particle. I'll grab something from Fluid Dynamics. I believe this is the one that I used last time. It's a great example. So I'm just going to open the video by itself to start. So this video is a Windex bottle. So Windex is a brand of window cleaner. So this was a spray bottle of window cleaner that was sprayed sideways in front of a high-speed camera. And behind on the other side of the spray from the camera was just a piece of paper, I believe, just a normal white piece of paper, but it was being lit from behind, so it glowed, and then everything in front of it, all of these spray particulates, just appeared like black dots. Now there was a really shallow depth of focus, shallow depth of field. So some of these are out of focus, some of them are in focus, but I can correct for that doing some simple image processing if I wanted to make sure that this one, for example, was included. So I want to know for every frame how many particles there are, what sizes they have, maybe how close they are to circular. If they're not circular, and I can figure out their major and minor axes, what is the angle between the major axis and the horizontal? That might give me some indication of which direction it was going in, for example. So for all of these sorts of things, I will turn to the particle tracking toolkit. So contours right here, you can see hopefully this little icon of a contour. And right beneath it, you have a bunch of particles, and some of them have their major and minor axes highlighted there. So I'm going to open that up. I'm going to enable it. And immediately I'm asked about what region of interest I want to use. I want to use the entire frame, but if I have a video with a lot of clutter in it, maybe I can define some region, I can set it, and then ProAnalyst will only look for particles in that region. For now, I'm going to turn that off. I'm going to make sure that I'm looking for the right color particle. So ideally, you're working with black and white images. And once again, you can convert to black and white in the lookup table toolkit if the video is not already black and white. But since it is, I just want to make sure that I'm looking for black particles on a white background. I can set some threshold. So everything above the threshold will be considered white and everything below will be considered black. I'll leave that alone for now. And then here I can specify my minimum and maximum area in pixels for each one of these particles. So some of these smaller ones like this, that might only be 4 pixels, 1, 2, 3, 4. Some of the larger ones, like this one, are many more. This could be close to 100 pixels. So I can rule out the ones that I don't really care about. For example, I don't want anything less than 10 pixels in my first pass. But I do want everything up to 1,000 pixels. So it's going to look for everything in that range. It's going to look for all the angles in this range for the angle of the major axis with respect to the horizontal. And it'll look for all values of eccentricity. So things that are close to round, it'll grab. But things that aren't that close to round, it will also grab. So that's all the setup that I need. And now I can just click the Track This Frame button here near these track arrows, and it will go through and it will find everything that it considers to be within these parameters that I've set. I see that it selected a couple things up here. This is sort of a darker gray because my threshold is so low. Or actually, yeah, because my threshold is where it is, it thinks that that's black. I can very easily solve this by just doing some very simple LUT adjustments here. Let's see. Yeah, so I'll do that, for example. And I'll click it again, and now it's only grabbing these things. So for every particle that it finds, let me zoom in on this one. You can see, first of all, there's this, this cyan box, this light blue box around the outside, and it tells me the dimensions of the box. It's 13 pixels by 23 pixels. But then it also highlights the edges of the particle in green. There are these lines here. That is the major and minor axes of this particle. So it thinks that it's not round, and it thinks that the longer dimension is this way. And then I get all this information listed to the side of it. I have this, the center in pixels because I haven't calibrated this video yet. So the XY of the center, its size, which is going to be the total area in pixels. And that's just going to be the count of pixels. That's not going to be pixels squared. So it'll give me just the exact count of how many pixels are in there. I get information about the angle, and then I get the eccentricity, which is how close it is to circular. So you can see for every particle that was within my parameters that I set, I get an outline, I get the bounding box, I get my major and minor axes, and then I get all this listed information. And I can change how much of this is displayed. I can very easily get rid of the label, so all that information is no longer displayed. I can get rid of the centroid, which is that white dot there in the middle. I can get rid of the particle outlines, major axis, and the bounds, and now it's just back to normal. So you can control how this is displayed. It makes for a great visualization tool. And now that I've tracked one frame, what I can do is, if I'm satisfied with these, maybe I'm not. Maybe this one, I look at this and I say, oh, that looks like a particle to me. It's counted out because it's less than 10 pixels, but why not include it? So I'll change my minimum to 4, and when I click the track button again, it'll grab that one because it now is within my user set parameters. And now I can just click track forward. And as you can see, it'll just go through the entire video, and for every frame, it will find all the particles that apply, and it will place the center on them, it'll outline them, and so forth. So you can see that as we go further on, there are more and more of these smaller particles that are either, that are between 1 and 3. If I track backward instead, let me go to close to the beginning here. There we go. If I track backward instead, which is very easy, you'll find everything that applies, and you can see that near the beginning, all the particles are quite large. So that's particle tracking. It's very simple, and this is a spray, so this may not apply to everyone. This is great for spray in fluids, but think about a ballistics experiment, some explosion, some detonation, and you have shrapnel. You have these little particulates flying through the air, and you want to capture how they're moving with respect to some coordinate system. You can record with your camera, you can bring it into particle, and as long as they are a different color than their background, so if you have a very light background and your shrapnel or your particles are dark, or let's say you're doing something like recording someone welding, or some other process where you have a lot of sparks flying, and a spark was just a tiny white dot on a dark background, and so that makes for a perfect application for particle tracking. And now that I have this tracked, once again, just like in Contour, I can go in and I can add my graph lines. It knows that I've looked at particle. And I want to point out here the difference between particle tracking and feature tracking, because with particle tracking, there's really an emphasis on the group. It's not really as much about one particle as it is about the group of particles. So all of these quantities that you can graph relate to averages. You have the total number of particles, right? You have the average size, the average angle, the average eccentricity, the average speed, which I will get to in a moment, the average direction, and then, yeah, some velocities. That relates to something that I can demonstrate in just a moment. But a lot of these relate to the group averages. And so that's the difference. In feature tracking, there's an emphasis on the individual. Every feature is unique, and the individual matters a lot. Whereas particle, there's more of an emphasis on a group. You have a large number of particles and you want to get group information. But if you ever wanted to track something in particle and then analyze it in 3D, you can with the virtual points tool available in full parametric feature tracking. So being able to import particle data to feature tracking, really, it can't be overstated how important it is. Here you can see contour tracking, particle tracking. Those are options for me to import into feature tracking via the virtual points menu. So that's a really cool tool for people to take advantage of. So the last thing I want to demonstrate, we have a few minutes left here, with respect to particle is you saw that I could graph things like speed and velocity. And in this example, the spray, all these spray particles, these liquid particles, are moving really fast. In fact, you don't see any particular piece of the spray for more than a single frame. So there's no way to get any understanding of the speed, because they're there for one frame and then they're gone and you don't see them again. That's not always the case. And I'm going to show you an example that is from biomechanics, so it won't be applicable to everyone, but I'll talk about how it can be applied more broadly. I'm going to show an example of when you have a video with a bunch of particles, but they are moving slow enough that you can see them in multiple frames. And that's when we get to what we call correspondence trails. So let me go to this one here. This is a video of a sea anemone. So this is an animal underwater that lives at it lives at the bottom of bodies of water, and it doesn't move, and it just grabs its food from around it. Sometimes it has these tentacle-like structures. This one is just sort of a cone shape. You can see it right here. It's this bright white bit, and I think there's one right here as well. These are sea anemone, and all of these white dots that you can see floating through, this is water that these are floating through. Those are food. So this is a video of someone feeding the sea anemone, and these are food particles floating through the water. And you can see as I scrub through that, unlike in the video of the spray, some of these particles remain visible for multiple frames. And so with the particle tracking toolkit, you can get information about how they're moving across multiple frames. So I'm going to just load that up here to save some time. This here is the same video, but it's gone through some simple image processing to, let me hide this for a moment. Go to display layers, hide particle tracking. You can see that they just hid the sea anemone. The sea anemone was here, and they used image processing to turn it black, just so that the particle tracking toolkit doesn't grab anything that it's not supposed to. So let me show particle tracking again. So this was done just as before. You can see each of these is a little particle. It's outlined. It has a bounding box. It has major and minor axes. It has a centroid, and it has all of this information in the label. And this is done for some set of parameters. And when I scrub through the video, you can see there are the particles. Now, of course, some of them appear and disappear because they are in accordance with the parameters. They fit the parameters for a moment. And then the next frame, the lighting changes and they no longer fit the parameters. So, but some of these persist for quite a while, and that's interesting to me. I could see this again in ballistics. If you have shrapnel flying through the air, some sort of particulate, you can get trajectory information just by recording with a video and then using particle tracking. So all I have to do here is check my correspondence settings. There's this big button here that says correspondence settings. I can choose the maximum distance that a particle can move before I discount it. So if it moves more than 20 pixels between frames, then I'm saying, oh, well, that couldn't be the case. It's moving way too fast to be the same particle. Or I can say, well, if it deviates by more than 30 degrees along its path, then it can't be the same particle because nothing is making sharp turns in the air. And those are user set parameters. So you can choose these to put whatever you want. And then there's also different weights for distances and size differences so that you can figure out where particles are at any given point. And with that set up, all I need to do now is check particle trails. And these orange lines that appeared, let me hide the labels here. These are my correspondence trails. These tell me where the particle is at any given point in time, and specifically in the past. So these trails over the anemone here, that's where the food particles are going, and from that I can get information about the flow of the water even. I can get information about the trajectories of each of these food particles as they advance in both space and time. And this is the information that I can then graph in the graph configuration. This is my average speed, average direction, and so I can get information about those as well. So you can see that they're moving. The average speed is relatively constant, so they're moving at a relatively constant speed throughout the whole video. So we are pretty close to the end at this point. That is correspondence. I think I'll leave this video up in case anyone has any questions about this, but that's particle. I talked about contour tracking, and I talked about the different 3D analysis toolkits available in ProAnalyst 2023. And once again, there's no technology required. There's no upgrade from the IX introductory or IX Lite toolboxes required in order to make someone eligible for obtaining these toolkits. They can take their existing toolbox and they can just license these toolkits on top of it, and then they'll just work flawlessly with their technology.
All right, thank you, everybody.
Thank you, everyone.
Appreciate it. Thank you.
Thank you.
Have a good day.